So we will get that area of triangle is sin theta into cos theta into r square by 2, where r denotes the length of radius. Sin theta into cos theta whole divided by 2. So we know adding the areas of 10 triangles, we will get that 10 into sin theta into cos theta into r square whole divided by 2. Cancelling, we will get 5 of sin theta into cos theta into r square. Now we can see here that 5, which is the number of sides in a polygon, and sin theta into cos theta. Now can you find the value of theta? Here, as we have studied in the class 8, the sum of the internal sum of internal angles of a polygon is n minus 2 into 180, where n denotes the number of sides in a polygon, which is the sum of internal angles of a polygon. So sum of internal angles of regular polygon is sum of all angles in the polygon. So which are equal in a regular polygon. We can denote it. So we can get the sum of each. So we can get that in a regular polygon, the measurement of each angle is n by 2 whole into 180 whole divided by n. So here we can get that the measure of each angle in a polygon is n minus 2 into 180 whole divided by n, which is equals to the angle BAE, or the measure of angle, which, as you know, that all 10 triangles are congruent. So the measurement of angle BAE is also equals to 2 theta, or twice of angle of theta. By this we can get that twice of theta is equals to n minus 2 into 180 whole divided by n. So theta is equals to n minus 2 into 180 whole divided by 2n. Now here in a pentagon, the value of theta is 5 minus 2 into 180 whole divided by 5. Which we'll get as 54. So we can write the area of pentagon as 5 into sin 54 into cos 54 into r square. Okay, but we have find this the area formula to find the area of regular polygon, area of regular pentagon, which is 5 into sin 54 into cos 54 into r square, where r denotes the length of circumcenter of the pentagon to the vertices. Now, but we can sin 54 into cos 54 into r square as sin 5 minus 2 into 180 into 2 into 5 into cos 5 minus 2 into 180 into 2 is to 5. Now here 5 is number of sides, so we can replace 5 with n. So here we get that sin n minus 2 into 180 by 2n into cos n minus 2 into 180 into n into r square. Cancelling 180 and 2. we will get so here we will get that sin n minus 2 into 190 divided by n into cos n minus 2 into 90 divided by n into r square. So multiplying 90 into n minus 2 will get sin 90n by 180 into cos 90n minus 180 whole divided by n into r square. Here we get sin 90 minus 180 by n into cos 90 minus 180 by n into r square. Using sin a minus b and cos a minus b identity, we will get that sin 90 into cos 180 by n minus cos 90 into sin 180 by n into using sin a minus b and cos a minus b identity, we will get that sin 90 into cos 180 by n minus cos 90 into sin 180 by n whole multiplied by cos 90 into cos 180 by n plus sin 90 into sin 180 by n. As we know the value of trigonometric ratios, we will get that sin 90 is equals to 1 into cos 180 by n minus cos 90 into sin 180 by n, which is equals to cos 90 is equals to 0. So of course sin 0 into 180 by n is also equals to 0, which is whole multiplied by cos 90 into cos 180 by n plus sin 90 into sin 180 by n. By simplifying this, we will get that 0 minus 0 plus 1 sin 180 by n into r square. We will get into sin theta into cos theta into r square as this. Further simplifying, we get that cos 180 by n into sin 180 by n into r square is value of sin theta into cos theta into r square, and multiplying this with n, we get n into cos 180 by n into sin 180 by n into r square. So final. It can be further simplified, but we are stopping this here. So we'll get that area of regular polygon is n into cos 180 by n into sin 180 by n into r square, where r denotes the length of vertices from the circumcenter of a polygon.